So let's put again the NAT configuration. Let's put this to be IPNAT inside, this to be IPNAT outside, and let's NAT all traffic flowing this way into the gig01 interface to do path. So problem was routing in here. To confirm that, if we go and tell it again before we do NAT, to confirm that if we go and tell it again, and we go under the on route 1 and we say show policy firewall session, we see that the packet from PCA went out direction wise. So it was sourced from PCA, it was destined to route 3's telnet port, but it says TCP since 10, so it's an embryonic connection. It's a half open session because router 3 does not have a route back to the subnet. So let's put interface gig00 IPNAT inside, gig01 IPNAT outside. So show IPNAT statistics. Let's make sure I have those two interfaces NAT inside outside, which they are. And let's go under my NAT configuration, remove the NAT statements and put something simpler to put in there, just a path config. Note this. For a very specific reason, note this. And let's say IPNAT inside source list. Let's see what is the internet list. Do show access list. I'm gonna use this NAT ACL. So IPNAT inside source list NAT ACL, which matches on v911 as the source. I'm gonna say do path into the interface of gig01, the internet one. Okay. Now let's go on PC and tell it again, because now we fixed the routing problem, because all traffic leaving this VLAN going out on the internet is going to get netted to this gig01 interface of router 1. Let's go back on PCA, CLS, tell it again. Cisco, let's say who. And as expected, I'm seen as the IP address of router 1 because I'm doing path. Now if we go in the firewall on router 1 and we say show policy firewall sessions, then we see that a session was created as a session ID from PCA random source port number to router 3 telnet port number. And session is established, TCP established. We have one established session, it's not embryonic anymore, and we have traffic back and forth being sent through that session. So the fact that the router inspects, because I said inspect action, it means, as we see, that for the moment what we have to understand minimum is that the router creates an entry in the firewall state table as the session is created, in order to allow the return traffic. That's stateful mode. So as the SYN goes out, the router marks put those values of that session in the state table, in the firewall state table, so that as SYN ACK comes back in, the firewall looks in that state table to see, have I seen the SYN going out? And if, because it has the SYN going out, it allows the SYN ACK to flow back in. So inspection is like a regular firewall, regular stateful firewall inspection. As long as the session is allowed to go out, then it's being inspected. It means that return traffic is allowed back in. Now, if we want to send ping traffic from PCA to router 3 out, it's going to be dropped because I'm going to match on the class default. Because if you look at our config, so my config states that traffic going in the direction of source LAN, destination internet, is controlled by this policy map. And that policy map states, so when I send traffic through source from the LAN destined to the internet, the router is going to parse top down that policy map. And now it's going to be ICMP traffic. It's going to parse and look at the first class map and say, do I match with the ICMP traffic in this class map? Of course not, because it matches only on UDP and TCP. Then the firewall states, okay, do I match with the ICMP traffic on the next class map? And it is going to match because this is the class default, which matches on all traffic. And as I stated before, it makes sense that whatever you don't specifically configure as a class map as an action, which means traffic which you have not defined, you have not told the router what action to take, it makes sense that it's going to be dropped by default, correct? Because this is what you would want to a certified firewall to do. You tell him which traffic it's allowed and what to do with the traffic, and then everything else should be dropped, correct? So if I ping now, it's not going to work. Ping. There we go. Doesn't work because I'm matching on a class default. If we say show policy file, let's see how many packets do we send out there. It's going to be 4 packets probably is going to send. Yeah, 4 packets is going to send the PCA. We have 4 packets being sent. If we say show policy firewall stats, if we look at the show policy firewall session, not session, show policy firewall stats all. If we look at this zone pair, and look at the class default, which matches any, I matched 4 packets, exactly my ICMP packets. If we say show on policy map, let's put additionally the log action in there, drop log. And now ping again, we should see the firewall sending a log message as it drops packets. And there we go. So it says dropping ICMP session from PCA to router 3. This traffic matched on a zone pair ZP LAN internet because traffic flows from the LAN to the internet. And in the policy map attached to that zone pair, the ICMP traffic matched on the class default, which has a default drop action, and there we go, firewall traffic was dropped as expected. So now if we want ICMP to work, we have 2 options, show run, policy map. How do we go in this class map and we also match on ICMP? That's one option, because it's of type match any. Or you could define a new class map. Class map, type inspect, and it's going to be of type ICMP, and I say mesh protocol ICMP, and then I go in that under my policy map, which is this one, and I say class ICMP. Class, I call in the new class map of type ICMP, and I say inspect likewise. So show route policy map. So now as traffic goes from the LAN to the internet, the router is going to first look if the traffic matches that class map. And if it's TCP/UDP is going to match it, it's going to inspect it. Then if traffic doesn't match that class map, like if it's ICMP, it's going to match the second class map, which has an inspect action likewise. If traffic is not TCP, is not UDP, is not ICMP, it's going to match on the class default with a drop log action. So now pinging should work. There we go, it does. And if we say show policy firewall session, we see the ICMP session from PCA destined to router 3, and we had traffic back and forth. And as expected, because we send 4 packets in there, we send 4 packets. If we go now and say show policy firewall stats all for my zone pair LAN to internet, if I look in the class map of type ICMP, in the class map of type ICMP, where I'm matching on ICMP, I should see, there we go, it's 8 packets. 4 in, 4 out, right? 4 echo request, 4 echo replies. Okay. It's a question from Matthew. Christian, is there any order of operation issues on iOS with traffic inbound and outbound when using both firewall and net? I'm going to do that in the next section, okay? In the next configuration option. But so we saw in here a very simple configuration with 2 zones. Now, if we remember what I said on the slides, that the zone pair defines the direction of the firewall policy from LAN to the internet. And as long as you inspect traffic flowing in that direction, LAN to internet, because it's inspected and the firewall creates an entry in the state table, return traffic is automatically allowed in. But if in that direction of the traffic I would put a pass action, which, as I stated, you would put a pass action only for traffic which cannot be inspected, like ESP and GRV. If in this firewall direction I'm going to have for one type of traffic a pass action, which, as I stated, this is like a regular, you can look like the pass action like a regular ACL, which is stateless. Traffic is going to go out, but return traffic is not going to be allowed back in. So when a router receives a packet on a zone firewall enabled interface, it first is gonna look in the firewall state table to see if it has an entry matching that traffic in the state table. Like as I stated in here, if you inspect TCP traffic going out, LAN to internet, the router creates an entry in the state table. And as return traffic comes back to the router, it's going to look in the state table to see, do I have an entry in the state table for that exact flow? And because it inspects it, it is going to allow the traffic back in, the return traffic. If the firewall doesn't see an entry in the state table, then the second step it's going to do is going to inspect the firewall configuration. So like as you're going to see, if I send traffic from the LAN to the internet, like ICMP, with a pass action, which means there's no entry created in the state table. So that's going to be the echo request. As the echo reply comes back, as the echo reply comes back, the echo reply. The firewall looks for the echo reply. Have I seen the echo request? Have I put that in the state table? No, because I have not inspected the ICMP echo packet going out. Then it's going to look, okay, for me to allow this echo packet, what is the firewall configuration? And because in the direction of internet to LAN, so this is the LAN side, and this is the internet interface. So I send an echo request packet out. It's not inspected, it's passed. Stateless means stateless mode, echo request. Matches a pass action. So no entry in the state table. As the echo reply comes back in, the router says, do I have that in the state table? Do I have that entry in the state table? No. Then second firewall says, what is the firewall configuration? And because the traffic, the echo reply flows in the direction of internet to LAN, and I have no firewall policy in that direction, echo reply is going to be dropped. So it means that if I'm going to do a pass action for ICMP going LAN from the internet, because there's not going to be any entry in the state table, if I want that ping to work, means echo reply to be allowed back in, I have to build a firewall policy from the internet to the LAN, match on ICMP, and pass it. So clearly for this reason, in general, you're not going to use the pass action. You're going to use it only for protocols which cannot be inspected. Because pass means stateful, it means stateless action. So you just allow the traffic to flow one way, but the return traffic is being dropped. You need a firewall policy with a pass action for the return traffic as well. So let's see that. Let's go on router 1 and change that firewall configuration so that ICMP traffic is going to be pass. So let's say no inspect, and say pass would also log to see that packet was allowed out. And let's see that now ICMP echo is not going to, so ping is not going to work. Let's go on tree, say debug ICMP, there you go, debug is turned on. So now let's go and ping from PCA to router 1. I'm going to match on the pass action, the echo reply, the echo request. And then when echo reply comes back in, it's going to be dropped because the router doesn't have the echo request in the state table because it matched the pass action, and there is no firewall policy in this direction from the internet to the LAN. There is no firewall policy, which means it's going to be a default drop. And this makes sense, right? This is what you want to do, because out there is the internet. Because if this is the internet and this is the LAN, you control what traffic goes that way, in LAN to internet. You inspect it so return traffic works. But you don't want anybody from the internet to be able to send traffic in the LAN network, correct? So let's go and ping again, and it should fail. If you look on the router, in here on router 1, I'm passing it. So traffic matched, ICMP traffic matched on my zone pair LAN to internet. And I'm passing the packet from PCA to router 3. Router 3 receives the packet. It sends the echo reply back in, but router 1 drops it. So the echo reply is dropped by router 1 because 1, there is no entry in the state table, for that return traffic. 2, there is no firewall rule, firewall policy in that direction, internet to LAN. Because the same thing, if I want to send traffic from the internet to the LAN, it's dropped. Let's try and ping from router 3 to router 1. It's not going to work. If we go on router 3 and say show IP route, the loopback of router 1, I have a route. Well, it's actually destined to the self zone. So I'm gonna explain this example when in the next example, in the next use case. But now again, if I want ICMP to work, because I passed the echo request, I need a firewall policy in the reverse path direction to pass the echo reply likewise. Which of course is not something which you want to do in production network. That's why the pass action should not really be used. Only in cases where you cannot inspect the packets in there. So it means if I want that to work, I'm going to build in here in Notepad another, I'm going to say class map. I'm going to make use of the same, so of course class maps can be reused. So now my configuration on router 1 actually looks like this, show run class map. I have also this class map configured in here. And show run policy map. I have that also enabled. This is how now my configuration looks like. So I'm gonna reuse that ICMP class map. I'm gonna build a new policy map. I could use the same one, but doesn't make sense in general. Policy map type inspect PMAP internet to LAN. Internet to LAN is the reverse direction. And I'm just matching on ICMP, and I'm saying pass log. And then I build a zone pair security named ZP internet to LAN, in that direction, internet to LAN, where the source traffic is being sourced from the internet zone destined to the LAN zone. So if traffic flows from the internet to the LAN, then I'm saying service policy type inspect this policy map. Let's paste this, and now pinging is going to work. Let's go on PCA now. Ping again. There you go, now it works. And router 1 should, we should see 2 log messages. Show run policy map, because we said pass log for both of them. Sometimes we don't see. We see that it worked as expected. And if we go and say now, let's say clear policy firewall, let's do this, clear policy firewall stats. Let me look again and show policy firewall stats just to make sure those got cleared. All. Okay. Let's ping again. So we have 4 echo requests and 4 echo replies. If we say show policy firewall stats, all, and we look in the direction of LAN to internet, we see that ICMP class was 4 packets, 4 echo requests. And in the reverse direction, internet to LAN, ICMP class was 4 packets. The echo replies as expected.